Parts of an atom. In this worksheet, you'll be filling in the data table at the bottom based on the information given to you in the left-hand column. The example that we have here, you can see that it gives you an element symbol. The mass number is at the top on the left, the atomic number is on the bottom left, and the charge is on the top right. So what you'll do for each of these is determine the atomic number, the mass number, the charge, protons, neutrons, and electrons. Now, for the number of protons and the atomic number, that's pretty simple right here. It tells us the atomic number is the number on bottom, so all I have to do is look that up. If it doesn't give me the atomic number, for example, down here on Mg, it doesn't give me the atomic number, so I need to look it up from the periodic table. So I'm going to find Mg, find its atomic number, and put it here. Now remember, the number of protons is equal to the atomic number. So in the example here for carbon, notice it has an atomic number of 6, so it has 6 protons. The mass number, which is the top number on the left of each of these, you're going to write here, and the mass has to be the protons and neutrons combined. Those are the two particles that have enough mass to count in the atomic mass. So you're going to make sure that your protons and neutrons add up to the mass number that is given. So that's why we would have 6 protons and 6 neutrons to make a total of 12, because 6 protons already came from the atomic number. Now the number of electrons is going to be a little different from what you've seen before. The charge is going to be in the upper right hand corner here. If it doesn't have a charge, then it doesn't have a charge. So if there is no charge, the number for no charge is 0. Make sure you put a 0 here if there is no charge. Now, if there's no charge, then the number of protons and electrons will be equal to each other. Protons, remember, are positive, electrons are negative. So if there is no charge, then the positive and negative charges had to cancel each other out. So with this one, there was a charge, so the number of protons and electrons are not equal. So how do I determine how many electrons there are if I have a charge? Well, the way to do that is to see how much charge it has. In this example, with a +4 charge, this tells me I have to have 4 more positives than I have negatives, because my overall charge is a +4. Since my protons are positive, that means this number will be bigger. So since I had a 6 for protons, then this number has to be 4 greater than my number of electrons. So my number of electrons ended up being 2. So if you have a positive charge, you will have more protons than electrons. Now don't go changing your number of protons. Your protons will always be the same as the atomic number. The only thing you're going to change is your number of electrons. So again, a positive charge means this number will be greater, and you need to make this number smaller. If you have a negative charge, for example in fluorine here, then your number of electrons will be greater than the number of protons, so you'll make this number bigger so that you have more negative charges to cause that overall negative charge. Try it out. If you have any questions, please let me know.